Hello everybody, and taking a look at a quick lesson on 7.1, just defining random variables. Basically review, we've talked about discrete and continuous variables earlier in the course, and in chapter 7 we look at probabilities, based on different types of distributions we have, whether we have discrete distributions, different types of continuous distributions like a normal distribution, computing probabilities there, which is a lot of what we already did in chapter 4. But looking at other types of continuous distributions, like things that are called a uniform distribution and binomial distributions. So based on the type of distribution of data we have, the way we go about calculating some of these probabilities is going to be affected. So that's what chapter 7 looks at, okay, calculating probabilities for specific types of distributions. Okay, so here we're going to be talking about random variables, okay? A random variable is just a numeric variable whose value depends on the outcome of a chance experiment. It associates a numerical value with each outcome of a chance experiment. We study two types of numeric random variables, discrete and continuous. All right, so let's talk a little bit about discrete random variables. Okay, a random variable is discrete if its set of possible values is a collection of isolated points along the number line. Okay, basically it can just take on certain values, typically thought of as things we count. So some examples might include, like if we ask, how many siblings do you have? Number of siblings, right? We could gather data from a bunch of people, ask the number of siblings they have, but that's something we count. You can have 0, 1, 2, 3, or so on, whole number of siblings. You're never going to have like 1.5 siblings, right? Okay, number of siblings. This is discrete, okay? Number of anything we count, all right? Discrete does not always have to come in the form of whole numbers. Shoe size is another example of discrete data. We can only have certain shoe sizes, like say 5, 5.5, 6, 6.5, 7, 7.5, 8, so on and so forth. These are just specific values along a number line. Shoe size is 6 or 6.5 or 7. You're never going to have a shoe size of 6.8. Right? These are just specific values that we can take on. Okay. Another thing that's discrete is money. Okay, money is always thought of as discrete. You could have $20. You could have $20.01, but you're never going to have an amount of money in between those values. Okay, these are just specific values we can take on. And again, what do we do with money? We count money. Okay, so things we typically count are discrete, or if they can only take on certain values. Contrast that with continuous variables. Okay, a random variable is continuous if its set of possible values includes an entire interval along the number line, typically thought of as things we measure. So things that would be classified as continuous, things we measure length, or distance, we measure weight, right, or volume. These are things we measure. We measure area, um, temperature. Okay, these are all just examples of things we measure. These are continuous random variables. For example, for temperature, on a typical day in April, it might be 30 degrees out in the morning or 35 degrees out in the morning. And, in the afternoon, it gets up to 60 degrees. Throughout the course of the day, we started at 35 degrees, we got up to 60 degrees. We've hit every temperature in between. This is an interval. Every fraction of a degree, like to go from 35 degrees to 36 degrees, we've hit 35.234 degrees. Like we're going up continuously. We're any number along this interval. In fact, the sample size is really any infinite number of values within the interval. Okay, but we would write, the possible values here is the interval from 35 to 60. We can take on any value. Okay, so again, area, volume, temperature, things we measure, time is continuous. Okay, so those are just some examples. So let's take a look at a couple problems here and just classify whether we're dealing with a discrete set of variables or continuous. Okay. So in the first one, dealing with length of hair, that's something we measure, okay? That's continuous. A person's hair can be any fraction of a number of inches or centimeters long, from 0 if you have a shaved head, up to however long a person's hair could be, feet long, okay? But that's something we measure. Weight is something we measure. That's continuous. Weight of puppies, weight of kittens, weight of anything, okay? Weight of adults, something we measure, that's continuous. The number of bedrooms in a house, well, that's something we count. That's going to be discrete. Temperature is something we measure, continuous. The number of homework assignments given tonight, well, again, the number of anything is going to be discrete. You can only have certain values. You're not going to get 1.5 homework assignments tonight. Cost, that's money. Cost of college, cost of rent, cost of meal plans, cost of anything. If it's money, it's discrete. Okay, the location a dart lands on a dartboard. It can hit any location on that dartboard. Any infinite spot on that dartboard. Okay, location, again, is more like something we measure. Location, area, continuous. Fuel efficiency of a car. These cars get 20 miles per gallon, 22.3 miles per gallon, 30.1 miles a gallon. Okay, fuel efficient cars might be getting 45.107 miles per gallon, but it's something we measure. We measure fuel efficiency. That's continuous. Tension in pounds per square inch at which a tennis racket is strung. Again, we measure tension. That's continuous. Okay, so we see just some examples here. If it's something we measure, it's going to be continuous. If it's something we count, it's going to be discrete. A couple more examples. A car enters an intersection and the car can turn left, right, or go straight. Let X denote the direction the car went. What are the possible values of X? Well, there are only 3 things X could be. X could be the car took a left, the car took a right, or the car went straight. While not necessarily numeric in nature, this is a set of discrete data. There are only 3 possible values X could take on. In the next example, a point is randomly selected from the surface of a lake with a maximum depth of 100 feet. Let X denote the depth of the water at the randomly selected point. What are the possible values of X? So suppose we're looking down on the top of this lake, okay? At anywhere, the depth could be 0 feet down to 100 feet. By the shore, the depth would be close to 0 feet. Probably somewhere towards the center of the lake, the depth is going to be deeper. But I can randomly select any spot and I'm going to measure the depth at that spot. Well, here we're measuring, that's continuous. X could really be any value from 0 to 100 feet. We get this entire interval of values upon which X could be. All right, kind of like a side view. Here's the top of the lake here. And then maybe, this is like, going down underneath, right at the edge of the lake there. The depth is 0. At the deepest point, it's 100 feet. But I could randomly select any spot, call that X, measure that distance. Okay, and it can be anywhere from 0 feet to 100 feet, depending on where I took that. So again, these examples just show, sometimes we have discrete data, in which case we just have a very, limited sample space. Otherwise, we can have an infinite set of data on any interval. Okay, so just a quick lesson on 7.1, and we'll be looking at all sorts of distributions coming up. All right, so hang in there, shoot questions to me if you have them.